Hi everybody. Today I have a broken USB drive that I got from a coworker that we're looking at recovering the data from. So it was one of these Lexar plastic cased drives. Looks like the end was ripped off of it. And we are left with a mostly intact circuit board, which is good. Just a review of what's on here. We'll zoom in quick so we can point out all the key components. All right, now that we're zoomed in a little bit. So this side, we have one of these big, large black chips here. This is most likely NAND flash. The drive originally connected to 4 pads here. These 2 pads, it's hard to see, but have actually been ripped off the board. So it's not as easy as just soldering this back into place. And on the back side, again, we have a second NAND flash chip. And really, all the magic happens in this USB flash controller. It has the interface between USB and the memory. It also understands what the file system on this flash looks like. If you wanted to just take these chips off and put them on another identical flash drive, it wouldn't work. And the reason is flash NAND has a lot of errors in it. These chips compensate for those errors and they remap dynamically different memory locations to ignore those errors. So it's important that all of this unit stays together and we kind of have to repair it as is. We'll zoom in even more with a microscope image here. But what you can see in the microscope image or on the original picture, these 2 resistors right here that are in front of these 2 missing pads. Those resistors attach to the signal lines. So USB, for those that don't know, you have 4 signals. You have plus 5 volts. You have a data plus. You have a data minus. And then you have ground. The 2 resistors that we can see right there are connected to data plus and data minus. And the reason is those resistors help stop signal reflections. So you will find those on any USB product, typically on both ends. The good news there is we can solder directly to those 2 resistors, even with the pads missing. And in the microscope image, if we look at that again here, we can actually see that there were 2 small traces from each of those ripped off pads that go to those resistors, just as confirmation. All right, we're going to zoom back out and take a look at the larger project again. Looking at what we have here, I took the end of a broken USB cable, the charging end. This is from a micro USB for a phone. The charging end was broken. This end looks like it's fine. So what I did is I cut off the end. I pre-tinned the wires just to make it easier for this video. And we're going to trace out from the USB end, as though they're the same thing, what wire goes with which. Red and black, pretty easy. Most likely going to be power and ground. Probably don't need to trace those out, but we will anyways. The signals, plus and minus, we will trace out just to verify. But then once we trace all that out, we're going to solder these 4 wires onto the board where they need to be put, plug it into the computer, and it should last long enough to copy all of the critical data off of this flash drive. All right, so in order to trace this out, I've clipped a multimeter lead on 1 wire at a time. The multimeter actually doesn't fit under the USB connector, so I've just clipped a wire to another multimeter lead, and we can get that underneath here. So we're going to start from the left and go over. Okay. Furthest one over is red. So we're going to do red. Then we'll move to black, which should be the opposite side, because power and ground are spaced on opposite sides of the connector. Good. Black. Next we will do white. Okay. White. And we will do green just to double check that we didn't somehow probe the wrong pin. Measure twice, solder once. Okay. So now, using what we just drew out and this cable, we can solder these wires to exactly where they need to go on the USB drive. I'm going to go do that quick. Okay, so we've done the soldering. It's not the greatest soldering in the world, but it should suffice. All right, upon double checking my connections, everything is backwards. This is why you check twice. So for correctness of this video, we're just gonna relabel these. It's black, red, white, and then green, which are also the standard USB cable colors. This diagram I just drew without thinking about correctness off the top of my head to indicate that there are 4 signals, but to draw it correctly, next to 5 volts is actually data minus, and then data plus is always next to ground on the male connector end. So I have since updated the board, and we can zoom in a little bit here on this to see exactly what was done. And now we are ready to plug it in and give it a test. All right, so we tried to give it a test and it didn't go well. Windows claims that there is a problem with the device. And I think after studying the circuit board, I might have discovered what that is. We'll see if we can focus on this here. It's hard to see, but right there, there is a pad for a capacitor, I'm assuming. I think BC stands for bulk capacitance. And it's not a nice smooth solder ball. You can actually tell that something was ripped off of there. So my assumption is there should be a bulk capacitor similar to that one right there. I'm going to guesstimate around 10 nanofarads is probably appropriate, and I'm going to try and solder something on there and then see if that chip will start up. That is very possibly the culprit. All right, we're back after multiple tries. First thing was I was able to, if I can get into focus here, I was able to put a 0603 capacitor right there on that 0402 footprint. Still no success. Interestingly enough, I started probing everything because I have a USB power monitor here, and it was showing that I had 0 current pulling from this board. The board was never initializing. So I started checking all the resistors, and I found out that the signal termination resistors on the data lines were open circuit for both of them, which was odd. So I just jumped the wires past the resistors, which USB 2.0 is a low enough frequency protocol that you can get away without the termination resistors, especially because this cable is only 6 inches long. And lo and behold, as soon as I did that, it started up, LED blinked, opened it, and was able to get all of the data off this for my coworker. So in general, this was a highly successful experience. I think that about ends this video then, and thanks for watching.